Welcome to The Explainer. Today, we're diving straight into a fascinating and honestly surprisingly intense battle happening right inside the walls of residential homes. We're going to explore the really unique collision between Lake Michigan's extreme weather and historic 1920s architecture. To do this, we'll be digging into data and insights from First Choice HVAC out in Whitefish Bay, Wisconsin. So if you've ever wondered why trying to control the climate in a vintage home feels like a totally uphill battle, you are definitely in the right place.
Here's our quick agenda for today. 1. Weather versus vintage homes. 2. Common local HVAC failures. 3. The diagnostic difference. 4. The $5,000 rule. And finally, number 5, the 3-step service process. Let's jump right into Section 1, Weather versus Vintage Homes. So, why exactly do vintage lakeside homes seemingly destroy modern HVAC systems? Well, it's not just bad luck. As the source material makes super clear, it's basically a structural and environmental inevitability. You see, generic HVAC services often fail in these specific areas because the technicians just don't understand the battlefield they're walking into.
If we look at Whitefish Bay's housing stock, it's kind of like a timeline of incompatible tech. You've got 1920s homes featuring heavy plaster walls that drastically alter how air flows, not to mention the original 100-amp knob and tube wiring. Trying to run a modern high-efficiency HVAC system on that old wiring, it's literally like trying to power a supercomputer with a watch battery. Then, move into the 1960s, and you have outdated insulation standards, which means systems just have to work overtime to compensate for all that heat loss. Fast forward to the 1990s, and the carrier split systems that were super popular for new builds or retrofits back then are now hitting their end of life. Essentially, you've got century-old bones trying to run 21st century lungs.
It really is the perfect storm. On one side, lake effect weather brings brutal winter cold and heavy snow, forcing those furnaces to work way harder than systems even just 10 miles inland. Then in the summer, extreme lake humidity pushes air conditioners way beyond their normal capacity. And fighting back against that equipment is the vintage architecture itself. Tight, uninsulated basements trap the moisture. The limited 100-amp electrical panels trip under the strain. It's an environment that absolutely demands highly specialized local knowledge. Moving on to Section 2, Common Local HVAC Failures.
Based on the data from First Choice HVAC, we're looking at 4 main villains here. First up, heat exchanger cracks. Second, AC compressor failure. This is largely driven by that relentless lake humidity we talked about, forcing the system to just run endlessly, which can actually freeze the coils. Third is inadequate airflow. And this is often caused by ductwork being squeezed into historic homes decades after they were actually built, creating some massive inefficiencies. And fourth, those electrical panel limits, causing nuisance trips and power drops that can genuinely damage modern equipment over time.
Okay, we really need to hit pause here for a second because this is an absolutely crucial safety point. Basement moisture from high water tables and being close to the leak drastically accelerates metal corrosion. When a furnace heat exchanger cracks because of this corrosion, it creates a very real, very dangerous risk of carbon monoxide leaking directly into the home. In these lakeside environments, a cracked heat exchanger cannot just be safely patched up. The entire furnace has to be replaced. Section 3, the diagnostic difference. Standard industry approaches usually involve a technician just kind of guessing what's wrong or simply looking at the old broken equipment and swapping it out for a new unit of the exact same size. But the methodology outlined by First Choice HVAC is totally different. It relies on calibrated testing. They utilize specialized instruments to test actual airflow, adhere strictly to EPA 608 protocols for handling refrigerants using precise scales and gauges, and most importantly, they perform what's known as a manual J load calculation.
If you take absolutely nothing else away from this explainer today, remember this concept. A manual J load calculation means determining the actual heating and cooling needs of a house based on its current insulation, window quality, solar orientation, and exact cubic footage. Because think about it, if a company just matches your old equipment's capacity, they are very likely installing an oversized or undersized unit. Oversized systems short cycle, meaning they just turn on and off rapidly, which wastes energy and completely fails to remove that brutal lake humidity. On the flip side, undersized units run constantly until they inevitably burn out. Now, when replacement actually is necessary, a true, accurate quote has to factor in the reality of that older home across 4 key areas. First is equipment efficiency. Higher SEER ratings cost more up front but save you money long term. Second is ductwork condition. Do those retrofitted 1960s ducts need modifying to actually work right? Third is electrical adequacy. Does that original 100-amp panel finally need an upgrade to handle the load? And fourth is installation complexity, because navigating tight original 1920s basements definitely takes extra time and expertise.
Section 4. The $5,000 rule.
The $5,000 rule is just a brilliant mental math shortcut. Here's how it works. You multiply the estimated repair cost of your current unit by the system's age in years. If that resulting number exceeds $5,000, then replacement makes more financial sense than a repair. It's an objective, completely rational formula designed to stop homeowners from blindly throwing good money at dying units that are just going to fail again under the heavy stress of local freeze-thaw cycles.
Let's actually run the numbers on an example from our source material. Let's say a technician quotes you $600 for repair, right? And you know your furnace is 12 years old. Well, 600 multiplied by 12 equals $7,200. Because $7,200 is obviously greater than $5,000, the rule gives you a clear, totally objective signal that replacement is for sure the smarter long-term investment.
And just to give us a grounded, realistic financial baseline, the source notes that a standard HVAC service call in the Whitefish Bay area typically ranges from $100 to $250. This generally covers the trip charge, diagnostic time, and a basic inspection. Knowing this upfront really helps you avoid nasty surprises, and many reputable companies will even apply this fee toward the total repair cost if you decide to move forward with them.
Which brings us to Section 5, the 3-step service process.
The standardized framework used in this specific environment involves 3 really clear steps. Step 1 is call and dispatch. They prioritize an emergency response time of within 90 minutes, with trucks already pre-stocked for Whitefish Bay's specific vintage systems. Step 2 is diagnosis and repair, relying entirely on that calibrated testing we discussed earlier to ensure a first visit resolution. And step 3 is testing and follow-up. They don't just flip the switch on and leave. They run it through complete cycles, verify temperature differentials, and then actually check back within 48 hours to make absolutely sure the system is still performing flawlessly.
Ultimately, it all boils down to this one core philosophy. Fix the problem, not the symptoms. When you're dealing with a complex environment or century-old architecture is just constantly battling extreme lake weather, guessing is a luxury no one can afford. Objective measurements and strict adherence to technical standards are really the only reliable ways to achieve true climate control. Which leaves us with this final thought. Look around your own living space today. Think about the walls, the wiring, the basement. Is your home's original design secretly fighting your climate control? Because understanding your home's history might just be the absolute key to your future comfort. Thanks so much for joining me on this explainer, and keep learning.